Hi, kids. It's totally me, Mrs. Boyd. We're going to talk today about exponential growth and decay, which feels incredibly appropriate amidst the COVID-19 days in which we currently live. So, also, this is probably one of the most, if not the most, real world appropriate things I will teach you ever. Here we go. Exponential growth. We talked about graphing exponential equations. So exponential growth, if that is your coordinate grid, exponential growth is going to look something like that. It starts out really slow, and then suddenly it increases crazy fast. This equation here that's listed for you is the equation for exponential growth. And we're going to talk right now about what each of these parts mean. Y is let's call it the final value. And you'll kind of understand what that means when we do an example down here. A is your initial value. It's what you start with. T is time. It's doesn't really matter the value at this point. And R is the interest rate as a decimal. Whoopsie. All right, I'm also noticing up here at the equation, there's actually a typo. This N should be an R. So this should read Y equals A to the 1 plus R to the T power. All right, let's put what we've learned here to good use. Just as a word of caution here, there's not a whole lot of work to show. I'm gonna write the full equation down, and then we'll kind of talk through the calculator buttons that you'll want to use. All right, prize for a radio station contest begins with a $100 gift card. Well, that tells us right there, A, our initial value is $100. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5%. Well, that's our R. If we have 2.5% and we want to write that as a decimal, we need to do what? Pause, write it down. We need to move our decimal point 2 places to the left. I really hope that's what you wrote. So if we start out with 2.5, our decimal point is going to travel. There's this eternal number of zeros to the left. It's going to travel 1 and then 2 places to right there, and it's going to become 0.025. That's our interest rate as a decimal. So that's what R is. Write an equation to represent the amount of the gift card in dollars after T days. Well, T is what we don't know. So we're just going to write an equation, and T is going to stay T. Here we go. Y is what we don't know, the final amount. A is 100. R is 0.025. So that's 1 plus 0.025, and T is going to be to the T power. We can only simplify this just a little before we've got the final answer. We're just going to add, 100 can't change, but we're going to make in the parentheses 1.025 to the T power. And that's our final equation. Part B. How much will the gift card be worth if no one wins after 10 days? That means same so as above, except for now, T is equal to 10. So we'll use this same equation, Y equals 100 times 1.025 to the 10th power. I'm going to write to the side here the steps that I would do this if I were you. And that, in other words, that means this is how you should do it. So I would do 1.025, and then either that caret button or the Y to the X button or the X to the Y button, whatever it is that you use to make an exponent. 1.05 exponent 10 equals, and that'll give you another number. And then you do answer times 100 equals, and that's going to be your final answer. So if I'm using my phone as a calculator, which really hurts my heart because, you know, I hate that. I'm going to type in 1.025, and on my iPhone calculator, it is this one, x to the y. I touch that, and then I type in 10 and equals. At that point, I've got 1.2800845 and stuff. I don't want to round now. I'm not going to write this number down because the more decimals I have, the more accurate my answer will be. So I leave it here, and I'm just going to press times 100 equals. This now is my final answer. Y is going to equal $128.01. All right, so your calculator should say 128.00845 and stuff. Since it's dollars, we're just going to round to the nearest cent. The hardest part about this, to me, is making sure you have all your variables correct and then the calculator. That's pretty much all there is. I want you to pause it here and try the next one on your own about college tuition. Ready, set, go. All right, let's write down what our variables are. College tuition has risen 5% each year. That's our interest rate. We start out with 5%. We want to make that a decimal, and it is what? That's right, it is 0.05. We move that decimal point 2 places to the left. Each year since 2000, if tuition in 2000, this is going to be our initial value, was 10,850, write an equation for the amount of tuition T years after 2000. Well, T is not just going to be a year. You can't just put 2020 in here. That's the year that it is right now, in case you missed that. But it is going to be years since 2000. So 2000 minus whatever this year is what that's going to be. So let's write an equation. We've got y equals, final value equals, initial value A times the quantity, 1 plus 0.05, and that's to the t power, but our t is this special t. Haha, special t. And that's 2000 minus t is our exponent. So this is the equation. All we can do is simplify this one last time and add what's in the parentheses. 850, and that's 1.05 to the 2000 minus t. So that's our equation for this particular scenario. Now we want to predict the cost of tuition for this college in 2019. So where t is, we're going to write 2019, 10,850 times 1.05 to the 2000 minus 2019 power. Here's what I would do on my calculator. I would do, you know what? First, let's simplify. Y is 10,850 times 1.05 to the 19th power. Because 2000 minus, oh gosh, kids, I totally messed up here. Please forgive me. If we want to find t, I've written it wrong. And I'm so sorry. I hope you caught my error before I did. If it's years since 2000, it'll be t minus 2000 because we're going forward in years, not backwards. Holy cow, I'm fired. T minus 2000 here and here. And then here it's t minus, or got the quarantine brain. 2019 minus 2000. Oh, there we go. Now our exponent's 19. Good Lord. That was a long, drawn-out process. So on a calculator, I hope you did 1.05, this button, or this button, or this button, to the 19th power equals. And then leave it there. And then that answer times 10,850. Then that's your final answer. So let's walk through it on my calculator. I do 1.05 0.05 to the 19th power equals, and I get 2.52695 stuff. Then I take that answer times 10,850, and I get $27,417.41 as my final answer. So your calculator should have read 27417.40961 and stuff. Okay, I hope this makes some sense so far. It's really just plugging in numbers to your calculator, and it's different than things we've done before. So I'm hopeful that explaining it from a distance here is doing okay. Let's move on down to compound interest. This is what happens in your savings account. This is what happens on your credit card. This is what happens with your student loans. These are all compounded in different ways. This equation is correct, thank goodness, as opposed to the one above it that was wrong. Here's what these values mean. Capital A here means amortized value. That's the same thing as final value. Here we're just talking about money, and that means it's an amortized value. P is principal. Again, it just is the same as initial value. Look at where they're placed in relation to the parentheses. They mean the same thing. They're just different letters because we're dealing with money at this point. So amortized value, principal, little r is interest rate. Again, and this is in decimal form. Little t is time in years. This one's very specific. N is compounding periods per year. So if something says it's compounded annually, that's once per year. If it's compounded monthly, how many months are there in a year? 12. So there's 12 compounding periods per year. Quarterly, 4 times a year. Okay, you get the drift. It just depends on how often that interest is compounded, and that's the end value. So really similar to the one above, we just added that extra compounding period part. Let's do example 2 here. Maria's parents invested $14,000. Well, that is P for principal, $14,000. At 6%, well, that's my R as a decimal, 0.06. Compounded monthly, well, that's N. And there's monthly, there's 12 months in a year. How much money will there be in the account? That means the capital A is what? After 10 years. T is 10. Let's fill out our equation. A equals P, 14,000, times 1 plus R, 0.06, divided by N, 12, to the N times T power. That's as good as the equation gets. I don't want you to simplify it anymore from here. We're just going to do it with your calculator. I'm going to write over here again the steps that I would use. I would do 0.06 divided by 12 equals that answer plus 1 equals answer to the power of parentheses 12 times 10 in parentheses equals answer times 14,000 equals, and that's your final answer. So let me walk you through what that would look like on your equation here. So first, you want to start at the inside and work out. So first we have to figure out what this is, 0.06 divided by 12. I'm not going to write down any of these intermediate computations because I don't want a rounding error. So 0.06 divided by 12 equals. Then once I do that, I'm going to add this 1 to it, plus 1 equals. Now that I have this whole answer, the PEMDAS tells me I need to do the exponent. So I take this answer to the, in the parentheses here, 12 times 10 power. Or if you know that that's 120, just to the 120th power. And then that answer, so now this whole chunk is done. We have to multiply that by our principal, $14,000. So let's use my calculator and we'll figure out what this answer is supposed to be. So 0.06, oh goodness, 0.06 divided by 12 equals 0.005. I'm not writing it down. Plus 1 equals 1.005, not writing. To the parentheses, 12 times 10 end parentheses equals. Now I've got 1.81939 and stuff. That answer I'm going to take times 14,000. And that's my final answer. I get A equals 20. Oh, don't know what's going on with that. Oh, Lord, the pen went crazy. Let's try it again. A equals $25,471.55. Of course, there's 42764 and stuff after that, but this is what we care about because it's in dollars. We don't care about the fractions of a dollar. I want you to notice something. $14,000 at 6% interest, which is a whole lot of interest. You can't find a lot of interest like that right now. After 10 years is more than doubled or almost doubled, right? $10,000 plus more. That's impressive. This is the power of saving. And that's just a lump sum that someone threw in a bank account. That's not something that they deposit into regularly. Savings is important. Pause here. Do this next one on your own. It's the same idea. Plug in the answers correctly. Use what I've showed you about how to put it in your calculator, and then we'll meet back. All right, let's plug this business in here. We've got initial investment, P, is $300. Invested at an interest rate of 3.5%, which is 0.035. Compounded monthly, that means our N is 12. For 22 years, T is 22. We want to know what this equals. Let's plug it into our equation. A equals 300 times 1 plus 0.035 divided by 12 to the 12 times 22 power. So we're halfway there. Now let's put it in this calculator. We get 0.035 divided by 12 equals plus 1 equals to the power of parentheses 12 times 22 equals times 300. After 22 years, this person has $647.20. Not too shabby, right? $300. It did take a whole lot of time to increase in value, but that you just plunk $300 in the bank and you're ready to go. Perfect. I hope you've got that. Let me know if you have any trouble. Last thing we're going to look at, exponential decay. These values, these variables should look familiar. They're the exact same thing as exponential growth, except for, if you remember, on our coordinate grid, exponential decay starts out big and goes down real fast. So Y is your final value or amount. A is your initial value or amount. I can't write, apparently. R is your interest rate. Again, as a decimal form. One thing I failed to mention, if you can't remember the two places your decimal moves to the left, you can always divide it by 100, and that'll give you the decimal form. Okay, either one of those works. T is time. And with exponential growth and exponential decay, we don't care about the unit of time. With compounding interest, we absolutely do. All right, let's do a couple of these, and then you'll be off to your own devices. Fully inflated child's raft for a pool is losing 6.6% of its air every day. That means R is 0.066. The raft originally contained, that's our A, 4,500 cubic inches of air. Write an equation to represent the loss of air. So we've got Y equals initial amount, 4,500, 1 minus interest rate in decimal form to the T power. Again, like exponential growth, the only thing we can simplify is to subtract 1 minus 0.066. That is 0.934. So we can rewrite this. Y equals 4,500 times struggling. 0.934 to the T power. Now, we want to know when T equals 7, how much air is left. So Y is 4,500 times 0.934 to the 7th power. Put it in our calculator. I'll write down the steps over here. 0.934 to the 7th power equals, and then that answer times 4,500 equals, then there's your answer. So we've got 0.934 to the 7th power, and that's 0.0000006 and stuff times 4,500. Oh, I did that totally wrong. Forget that. 0.934 to the 7th power, holy cow, is 0.620052 and things, holy cow, times 4,500. Then we've got, after 7 days, we have remaining 2,790.23 cubic inches. Whew, that was a close one. See, the power of the calculator. You try the next one on your own, and then we'll be all done. All right, here we go. Campbell County, Kentucky is decreasing. That means anytime you see the word decreasing, that means exponential decay. At an average rate of, that means R, 0.3%, which turns into 0.003 for our interest rate. In 2000, its population, that's going to be our initial, was 88,647. We want to know what its population has been since 2000. So that means our T is going to be T minus 2000. So we've got Y is 88647 times 1 minus 0.003 to the T minus 2000 power. Just to simplify, 88647 times 0.997 to the T minus 2000 power. Now I want to know the population since 2010 or in 2010. 88647.997 to the 2, holy moly, 2010 minus 2000 power. So in my handy dandy calculator, I hope you have done 0.997 to the power of, parentheses, 2010 minus 2000 equals And take that times 88,647 equals, that means they should have 86,203 people. I'm not going to round because you can't have part a person. Hooray, we've totally done it. I hope this makes sense. It's a lot of plugging and chugging. But like I said, the hardest part is putting it in your calculator correctly. Final note, if you see increase, that's going to mean exponential growth. If you see the word compound or compounding or compounds, that is compounding interest. If you see decrease, it's exponential decay. Okay, those are your buzzwords. Increase, exponential growth; decrease, exponential decay. Anything about the word compound is compound interest. Best of luck. Let me know if you have any trouble or questions. I miss you so terribly. Stay healthy and safe. Bye-bye for now.